This video is on Unit 7, Chapter 14 on regression, lesson number 3, regression, choose the best fit. In your notes here, it says you have learned about linear regression, which is your line of best fit, as well as quadratic regression, which is also known as curve of best fit. Sometimes data is not linear, nor is it quadratic. Sometimes data that is collected can also be cubic, quartic, exponential, or logarithmic. And there are others, but we are just going to focus on these four here, in addition to the quadratic that we've already looked at in lesson number 2 and linear that we looked at in lesson number 1. So looking at our first example, it says the Millennium Force at Cedar Point is one of the world's most famous roller coasters. The table below shows the average number of people in line at each hour after the park opens. Use a cubic model to find an equation for the curve of best fit, then estimate the number of people in line 6 hours after the park opens. So the steps for this are exactly like the steps that you've learned about in lesson number 1 and in lesson number 2. But in example 1, it asks you to find a cubic model. Number 2 says quartic. Number 3 says exponential. Number 4 says logarithmic. So I want to show you where you would find this on the graphing calculator. If we look at the graphing calculator and we go to stat and we arrow over to calc, number 4 is linear that we learned about in lesson number 1. Number 5 is quadratic that we learned about in lesson number 2. In lesson number 3, we're going to focus on cubic, which is number 6, quartic, which is number 7. You have to arrow down to the next page in order to see exponential and logarithmic. Actually, logarithmic is number 9. It's that natural log, but it's logarithmic. And then the next one down is your exponential. So you'll use 4 for linear, 5 for quadratic, 6 for cubic, 7 for quartic, 9 for log, and 0 for exponential. Now I want to go back to our examples and I want to skip over to the next page, choosing the best model. Remember that data can produce a linear, quadratic, cubic, quartic, exponential, or logarithmic relation. There are others, but we will concentrate our studies on just these models. I've already said that. To determine the best model, use the correlation coefficient and the coefficient of determination. The correlation coefficient R is used to determine if the data forms a linear relationship. The closer the value is to 1 or -1, the better the fit. The coefficient of determination, which is your R squared, is used for all other relations, anything with a curve in it. The closer the value is to 1, the better the fit. Don't forget that diagnostics must be on in order to produce these values. You go to mode, arrow down to stat, diagnostics, highlight on, hit enter, arrow down to the stat wizard, highlight on, and hit enter. So let's look at one of these. So example number 5 says the table below shows the operating costs in thousands of dollars of a small business from 2000 to 2005. Which model would fit this data best? Quadratic, quartic, or logarithmic? Using the model, find the regression equation, then estimate operating costs in 2008. So I already know that I need to predict 2008. So we'll enter this data into our calculator. Remember that when you're given years, we always start with the first year being year 0. The second one, because there's only one year, is going to be year 1. And each of these is increasing by 1. So 0, 1, 2, 3, 4, 5. So I'm going to go back to stat, click on edit, arrow up, clear, and now enter my data. So I've got 0, 1, 2, 3, 4, and 5. For my cost, I've got 2.3 thousand, 2.6, 3.1, 3.4, 4, and 5.6. So again, those are y values are in thousands. So 2.3 thousand means 2,300. 2.6 thousand is 2,600, and so on. Now we're going to compare the three. And what that means is I'm going to have to calculate the quadratic, the quartic, and the logarithmic and see which one comes closest to um, 1. Now we're comparing the r squared here, not the r squared. Remember, r squared is anything with a curve in it. I'm going to go back to my calculator, and I'm going to do stat, calc. The first one was quadratic, so I'm going to select number 5. And honestly, y'all, it doesn't matter if you store these regression equations here, because right now we're just trying to compare. So the r squared value for quadratic is 0.9699. 0.9699. And this was quadratic. All right, now we got to do the same thing for quartic. So I'm going to go back, stat, calc. Quartic is number 7. Select number 7. Enter, enter, enter. Alpha trace. Enter, enter, enter. R squared is down here at the bottom. It's 0.9997. 0.9997 for quartic. Now, 0.9997 is closer to 1 than 0.9699. So I'm going to get rid of quadratic. Now I'm going to check log. Go back to stat, arrow over to calc. Log is number 9. Enter, enter, enter. Alpha trace. Enter, enter, enter. And it won't do it. So obviously it's not log. So let's go back and look at something just real quick. If I hit zoom 9 to look at the graph, you can kind of see there's an extra little curve in this, which immediately let me think that it's probably going to be the quartic. And looking at our data here, log, it wouldn't even calculate log, so it's definitely quartic. So I'm going to go back to stats, calc, quartic was number 7. Enter, 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 alpha trace, enter, 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 and there's my equation. Now, you'll notice with quartic, it says ax to the fourth plus bx to the third plus dot, dot, dot plus e. The screen doesn't have enough space for the cx squared plus dx. So you'll notice that they give you all of that data here. You just have to create the equation. A is 0.023. B is negative 0.178. C is 0.445. D is 0.027. E is 2.297. So I'm going to create my equation here. So go back and I'm going to write the equation. It's y equals 0.023x to the fourth minus 0.178x to the third plus 0.445x squared plus 0.027x plus 2.297. Was that right? Yeah, 2.297. All right, so there's the equation. Then it asks me to predict cost in 2008, which would be year 8. So because I stored the regression equation, it does make my life a little bit easier. If I go to second graph and I look at year 8, I got $33.6 thousand. Okay, so that's how that's done. I did want to show you a log function. So I'm going to go back up. Now, the steps for this are the same. You look at number 6, asking about linear, cubic, and exponential. So you'll have to compare those three. Remember, linear is the r, cubic is the r squared, and exponential is the r squared. So you have to calculate all those and compare and see which one is closest to 1. Or in linear case, it could be negative 1. I do want to show you log. So I'm going to go back up to number 4. table below shows the height in feet of a pine tree in the park. When it was originally planted, it was 1 year old and had a height of 4 feet. Using a logarithmic model, write an equation for the curved distance and determine the age of the tree at 20 feet. So again, data goes in to L1 and L2. So going back to my calculator, I'm going to go to stat, edit, clear out the old, and actually forgot to clear out my equation. So let me do that. Going back to stat, edit, I'm going to put in my x's. 1, 2, 3, 4, and 5. Now, I don't know if you've noticed or not, but in that table, the age is when it was originally planted, like how many years from when it was planted. So then I got 4, 6.3. So in year 1, it was 4 feet tall. That was the year it was planted. In year 2, it's 6.3 feet high. And then in year 3, 7.9, and then 9.2, and 10.3. And what we're trying to figure out is how old will it be before it gets 20 feet? I'm going to go to stat, calc. It asks me to create a log, which is number 9. Enter, enter, enter. Alpha trace. Enter, enter, enter. So notice your equation here. It says y equals a plus b times the natural log of x. And it gives you the value of a, 0.818. The value of b is 3.887. And then your r squared is 0.993. That's interesting. It's a very strong relationship here. So I'm going to go back and I'm going to write my equation. Y equals 3.818 plus, I'm going to put the b in parentheses just so I can separate it from my natural log of x. So there's the equation. If you wanted to look at the graph, Zoom 9 is going to allow you to do that. So you can see how well the data fits the equation that the calculator created. It hits kind of on all of the points. Some of them are a little off, but for the most part, it hits those data points. So now I'm going to look at the table of ordered pairs. Remember that represents the years. The y represents the height. And we're trying to figure out where does the y change over to. So at the end of year 17, I'm still at 14.8 feet. When am I going to hit 20 feet? This could take a minute because it's not going very quickly. Not sure what kind of tree this is, but it doesn't look like it grows fast. So at the end of year 58, I'm still at 19.6, 19.6, 19.7. So here we finally are. In 65 years, it's going to finally, in that 60th year, hit 20 feet. So that's how logs are done. There is your video for choosing best fit regression equation for lesson number